In this video, we will learn about partial fractions in integral in extreme detail. We'll not only learn about how to do partial fractions, but I will also show you when to do partial fractions because that's extremely important. 99% of the videos on the entire YouTube will just talk about how to do partial fractions. I will be the only one to tell you when to do partial fractions. So make sure you watch this video till the end. In order for us to decide whether we want to do partial fractions or not in the integral, there are two conditions that we have to follow. Condition number one is that power of the numerator should be less than power of denominator. That's the condition number one, and it is very easy to determine condition. Okay, obviously when the numerators and the denominators both are polynomials in x, power of numerator should be less than the power of denominator. Okay, that's condition number one. Condition number two is the denominator should be in factors or should be factorizable. So it should already be in factors, or if it is not in factors, you should be able to convert it in terms of factors of x. Okay, and then you can apply partial fractions. These are the two conditions that which are extremely important. If these two conditions, or even if one of these conditions is not satisfied, you cannot and never do partial fractions. Remember my words. Let's look at example of this in order to understand this even better. So in this case, I have integral of 1 over x square minus 9. First, let's see if the condition number 1 is satisfied. In this case, both are polynomials in numerator as well as denominator. Both are polynomials in x. The power of the numerator is 0. The power of denominator is 2. So the condition number 1 is satisfied, that power of numerator should be less than the power of denominator. So that's satisfied. Condition number 2, denominator should be in factors or is factorizable. I see that denominator is not in terms of factors, but it is factorizable. I can factor this out by, we know this is a square minus b square, and we can factor this by x minus 3 and x plus 3. By doing this, we can convert it in terms of factors. So yes, now both of these conditions are satisfied, that the power of numerator is less than power of denominator, and I was able to convert the denominator in terms of factors. Now let's see how do you apply partial fractions. So we'll get into now how to do it. In order to apply partial fractions, what you do is you say let. So you express that entire expression. So 1 over x minus 3 and x plus 3, you express that as a over the first term plus b over the second term. Okay, so we try to express that term as a over x minus 3 plus b over x plus 3. The moment you find the values of a and b, we are really done with partial fractions, and it becomes very easy to integrate at that point. Now let's see how do you find the values of a and b. This is also where most of the people on YouTube go wrong. There is actually a much easier way to find values of a and b. In order to find the values of a and b, first let's do cross multiplication. So we just do a cross multiplication here. So you have a into x plus 3 plus b into x minus 3 divide by x minus 3 x plus 3, and I have 1 over x minus 3 and x plus 3. We can cancel out that term, and we'll be left with 1 is equal to a times x plus 3 plus b times x minus 3. So now in order to find the values of a and b, what most people will do is compare left hand side and right hand side. It is not incorrect, but it is extremely inefficient way to find the values of a and b. What I like to do is just assume some values of x, and that will give you values of a and b. You can assume any values of x really, but I like to assume the values of x that will make some terms 0. So for example, if I put x is equal to 3 over here, this term will become 0. So let's just say I put x is equal to 3. So I get 1 is equal to a times, I have 3 plus 3 is 6 plus 3 minus 3, this will just become 0. So immediately I get a is equal to 1 over 6. How efficient was that method to find the value of a and b? In order to find the value of b, just put minus 3, because that would make this term is equal to 0. So I have 1 is equal to minus 3 plus 3 is 0 plus b times minus 3 is minus 6. So immediately I have b is equal to minus 1 over 6. How efficiently we were able to find the values of a and b. Wasn't that very cool? So now the moment you found the values of a and b, you can just substitute it over here. And actually you can just write our integral as, since the integral is a over x minus 3, so we have 1 over 6 over x minus 3, and we have minus 1 over 6 over x plus 3, and we are integrating with respect to x. Now we can give that integral to both of those terms. So we have integral of 1 by 6 times x minus 3 with respect to x minus integral of 1 by 6 times x plus 3, essentially just taking that 6 in the denominator, okay, in both of those cases, and splitting that integral in both of those terms. Now that 6 is constant, both in both integrals can be taken out of integral, so 1 over 6, and integral of 1 over x minus 3 is nothing but ln of x minus 3 minus, again that 6 is constant, so 1 over 6, integral of 1 over x plus 3 is ln x plus 3. Let's add the constant of integration, c, and this is nothing but your final result. You can clean this up a little bit by factoring out 1 over 6 and saying ln, you will have x minus 3, so let's factor out 1 by 6 minus ln mod x plus 3 plus constant of integration. See, you can apply now the formula ln a minus ln b is ln a divided by b. So x minus 3 divided by x plus 3 plus constant of integration c, and this is nothing but the final result of the integral that we are looking for. How cool was that partial fractions method? I hope that made sense to you. If you have any questions at all, feel free to post your questions in the comments. I do read each and every comments, and I will make sure to answer your questions within 24 hours. That is my promise. Also, I do post math and calculus content every single day. Please don't forget to like this video and subscribe to this channel so that you don't miss the next video. I'll see you tomorrow.